Hi, I'm Pat Deegan, President of Psychogenic Technologies. Today I'm going to be talking about actually using the LitePlacer pick-and-place machine. Now, it's been a good while since my last video on the topic, and in that time I've actually managed to produce a number of boards, about 70 in total of 6 different designs. Some pretty simple, others a little bit complex, and some kind of tricky like this guy. I've got hours of footage of a machine going bzz, which is really boring. So instead what we're going to do is just basically touch on the highlights, how I got the machine working, and then some tips and tricks about actually using the machine in production. Okay, so the story begins with calibration. So once you've powered it up for the first time, the first thing to do is to calibrate the thing. I was pretty lucky, it was nice and square. The steps are admittedly kind of tedious, but the LitePlacer site is abundantly clear, and there's no real problem getting it done. You have to be very precise with your measurements if you want to get stuff like fiducials working. And also a little bit of a tip is actually put on the diffuser. I hadn't at first, and it was kind of nice because the fiducial markings would kind of reflect the LEDs, and if you see a nice little series of dots, then you know that your camera is nice and flush and looking down straight. That's cool, but once you start trying to recognize stuff, it gets messy. So just stick on the diffuser and everything will be great. So the next test I did was trying to place a component one at a time. So just pick up a resistor and drop it somewhere. And once I got that working, a pro tip, you want a little bit of saliva. Yes, I lick my PCBs, and instead of paste, and it'll stay when it drops it instead of staying stuck to the nozzle. Anyways, the point is, once I got one component working okay, it was ready to start with these guys. Simple little boards with not too many components, nothing too small. It was a great first test, and I had to make 12 of them anyways. So I selected some very simple boards to do for my first run, and it went pretty well, except that's where I encountered my first problem. LitePlacer uses the bottom camera to correct the nozzle. So basically it goes and it checks the nozzle and it sees if it's offset when it's rotated by X degrees. And that sounds great in principle, but the whole process is a little bit opaque. So you don't really see what's going on. There's a bunch of numbers spitting out, but who knows what that means. And then you just go. And so it was working when they were 0 degrees, but whenever it was 90, it was way offset, and that was something wrong with the calibration. So I finally figured it out and then turned that off. And after that, all these little boards, like 12 of them, came out pretty good. There was a little bit of jiggle in the components, but otherwise, it was better than that horrible nozzle correction mistake. So otherwise, LitePlacer did its job very nicely. And I moved on to the second board. The next boards I did were these guys. They're perfect for a test for the LitePlacer because there's basically lots of components, but they're all repeats. So it's just a grid of all the same thing repeating over and over. This went well, relatively, except for one problem. Basically, the way the LitePlacer works is that it auto-determines the Z. So it goes down until the sensor clicks, and then it goes, okay, that's where the board is, and that's great. And then it remembers where that is for each component, and then if you have 50 of these guys, well, it'll just go to that Z real quick after that. Sounds good in principle, but there are two things that are so-so with that. The first is that you kind of mash down the components a little bit much. At least in my case, the spring is such that the sensor kind of goes down and then click, and then, okay, that's my Z. Well, the thing is, if you've got components with fine pitch and then it's a little off or whatever, anyways, you kind of make a mess of the solder there. The other thing is these boards are pretty long and kind of flexible. And I've got another version in red that is actually, because of the copper, it's got a little bit of a bump to it. So, that plus the way I was set up caused some problems at some point. It was, measuring at one point, which was lower than when it was hitting, and then it would actually trip the switch and die. So I reset the Z and things kind of worked out anyways. It's less trouble than with OpenPnP. It's automatic, which is wonderful, but at the same time, there are some issues, especially with the setup I ended up using for the feeds that we'll talk about in a little bit. Now, there was another problem with these guys. I had done my setup, the boards were pasted, they were ready to go, I was going to do 10, and the light had somehow changed in this place, and suddenly LitePlacer couldn't find the circles.
No fucking circles. That's not a circle.
Looks like a circle, not a circle. 120. Is that a circle? Not a circle. How about if I blur it? That fucking circle now. Couldn't find the fiducial markings. Okay, so I start playing with the calibration. I messed around for a ton of time. Is this not a circle? Don't be such a turd. Took me at least an hour to figure out that, okay, I can keep the color of the PCB and invert that, and then I ended up with this giant circle the size of the mask, and finally it would find the fiducials and work out. I'm so happy I made your board. Yay! But that was kind of it for me. I was a little bit tired of using the Windows system anyways, and LitePlacer softwares, and I wanted to try OpenPnP. So for the next boards, that's what I did. Now the next boards I got to make were these guys. Nothing too special, not my design, pretty simple, except that they have some small components, the BME 280 or whatever it is, and these other things. So this was a perfect opportunity to try out OpenPnP, namely because, okay, I get to use it under Linux. Also, the bottom vision. Ooh, okay, so using the camera for more than just nozzle correction, for actually checking out the footprints, the alignment of the parts as you pick them up before you place them. So that was kind of interesting. Now, of course, I had to learn how to use OpenPnP. I got the dev version 2 or whatever, and installed that and started setting it up. It's pretty sweet. I gotta say, I fell in love. Thankfully, the little module I made, the extension board for the LitePlacer, had a little switch that I could just change the Z, because the Z is inverted the way it's interpreted anyways. So you have to kind of rewire or use that switch. So the point is, OpenPnP, tasty. So in this run, I had 30 to do, and I didn't want to mess around with these tiny components. So I set up the bottom vision. I learned how to use OpenPnP. It took all about a half a day. And of course, you know, no software is perfect. However, here's a big upside. There's a whole scripting engine. If you can write Python, there you go. You can basically make it do whatever you want, which is really cool. Anyhow, I got these done, and it worked well. Not bad at all. That's okay. That's ugly as fuck. That's fine. Except for a couple of things. Namely, the choice of cameras. The version of LitePlacer that I got has these YUV cameras, and OpenPnP doesn't really kind of expect that and doesn't play too well with these guys. So you set up the bottom vision and it works. And then it doesn't work. And when it doesn't work, it can go really wrong. Shit. Suddenly your part is, 2 degrees off, but no, it thinks it's 45 and it'll just go. And there's no aborting, there's no interrupting, there's nothing to do. It's going to mash that component onto something else, if it's big. And yeah, make kind of a mess. But otherwise, when the lighting is good and the PnP gods smile upon you, OpenPnP really rocks. Now this run of 30 boards was simple, but it was 30 boards. And it really highlighted what I call the great feeder problem. So you'll have noticed these little 3D printed thingamajigs with my parts feeds, the strips. What I did was I basically started out trying to put everything at the same level. Now, both LitePlacer and OpenPnP basically need everything to be ideally in the same plane. So the parts and the boards and all that stuff. So what I did at first was use guys like these on boards. And the idea was to have some simple configuration where I could swap things in and out and basically always have the strips at the same positions to simplify configuration. That was kind of shitty because even though I had to kind of raise everything to get everything on the same thing, and these little corners I printed were great because you always had the same 0, wonderful, but it's too bouncy. So that was part of the Z problem with the LitePlacer. I had some bounce here and it caused some issues. So basically I went through a number of iterations. Some of them were total shit, and some of them were pretty great. Now I've settled on guys like these. Some of them are very flat, so that's great for components like 0603, 0402, anything that's really flat. It's great because you can kind of hit it and it won't bounce around too much. But then you have these thicker parts, these SOT 23s or whatever like that. And it gets really annoying having a different strip because you've got limited space on this table. So it's nice to have everything in one of these strips. So I've got these more universal guys, and they have greater depth. But the problem here is, okay, you've got this black plastic strip, cool, and all the parts are there, but they're kind of floating. So if you come in and mash down like the LitePlacer would do, everything's going to bounce, and then you're going to spend your day replacing these components in the right orientation, which is not all that much fun. So basically what you have to do is get the OpenPnP to come down to just the right Z so that it can suck in and suck the component. So just touch or whatever. So that's a lot of configuration, but it allows you to set up your table in a nice way without, having a bunch of different strips eating up all the space. The final boards I ran were these guys. They were kind of tricky because they have lots of parts, and they have radio paths that have 0402s. These are the big brothers, which are slightly different, but very much the same. Anyways, there's GPS and LTE and BLE and stuff like that. So I needed to deal with 0402s. Now, I set everything up with OpenPnP to use bottom vision and make sure everything was centered. That worked surprisingly well. And everything was pretty great, but I had a lot to do, and it turns out when the light changes, the problem with the LitePlacer YUV cameras kept cropping up, and I just turned it all off. And it turns out, with the nozzle correction working correctly, it doesn't really matter. Yeah, there's some jiggle, but on maybe 12 boards, I got 2 tombstone parts, and that was that. So just save the time and don't bother going for that, except for these chips. The BLE chip here is an NRF 5340, and this is a 9160. Those guys have a lot of pads. So if you can get bottom vision working with these things, which I did, it works fantastic. Even using loose part placement works quite well. With these guys, because they're so big, the bottom camera has trouble seeing the whole thing. Well, just the loose parts placement, that's pretty cool. All in all, OpenPnP was pretty awesome. The LitePlacer works quite well. OpenPnP works under Linux and other operating systems. It's transparent, you know what's going on, the bottom vision works, and it's scriptable. I've used all of this, and it works pretty terrific with the LitePlacer. The LitePlacer software itself works quite well. If that's what you're using, it'll be fine for most things, so that's cool. For me, it's going to be OpenPnP from now on. I've produced a bunch of boards with this, and it works really well. In conclusion, I'd like to say I really love the machine. It's saved me a lot of work, and it's been a lot of fun discovering it. I hope you enjoyed the video and found it useful. I'll be posting more information on the strips, the speeders, and my scripts for OpenPnP. If you're interested, just keep an eye on the channel. Thanks.